Good afternoon, everybody. So today our meeting's going to be pretty short because really more so of what we're doing for the in-class activity is going to be more individually focused. So our in-class activity 3 is published and live on Canvas. So I'm going to go through the instructions, what I expect, and then maybe go through a brief example, and that'll be our meeting. And of course, if there's any questions, please ask them. But just sharing, so all the folks at home, although I know we're probably all at home or just, not in a classroom, certainly, but so all the folks everywhere around can see. So this is our in-class activity. And what I want each of you to do is to pick one of these 5 topics. We have variance and standard deviation. We have normal distribution, categorical and quantitative variables, samples versus populations, and experiments versus non-experiments. So what I want each of you to do is pick out of those 5 topics, pick the one you are struggling with the most to understand it, to grasp it, to just get in general. I want you to pick the one that gives you the most trouble and describe what it is you know about it. So describe what you know about if it's normal distribution, describe what it is you know. And you'll see in the parentheses here, I've also included some prompts as well. If you're kind of thinking, well, I don't even know how to get started. How am I supposed to write about it? For the example of normal distribution, you see I say, how do we use the normal distribution? What is it used for? And then what are some characteristics of it? Samples and populations, how are they used? How can you tell a sample and a population apart? How do you know which one's which? And then some examples. So each of these topics have little writing prompts to get you started. But what I want, like I said, each of you to do is describe what you know. I want you guys to use your own words, your own understanding. And I want you to at least write 6 full sentences, just so you can explain to me how you interpret it. I'm the only one who reads it, and I've been teaching stats for long enough to hear all different types of explanations of all these different topics. So don't think you're going to surprise me. I'm not going to judge you. If you struggle to understand it, that's valid. That's completely understandable. And my purpose is to read what your understanding is, and then have me and your understanding meet in the middle. Let's bridge that gap so it's not like this, what the hell is even going on with experiments versus non-experiments or whatever your topic is. Let's bridge that gap so we don't have those big, I understood everything except this massive chunk. That's just a big blur to me. I don't want that to happen for any of us. So when you are picking get out of there, Petunia. Don't you sass me. Sorry, my cat's getting in my desk drawers. But yeah, so I want to be able to help you how I can. And I figure these are all pretty prominent on our exam that's coming up in 2 weeks. So I would these are really big topics, and not just for our upcoming exam, but also moving forward for the material after the class. So this is what I want. Write the best you can, use your words, your description of it, how you interpret it and understand it in your head. That's going to help me give you the feedback you need the most, as opposed to if you just copy and paste the bullet points in my PowerPoint slides. I already know that. You don't have to tell me what I've literally written down. Tell me what you know. With all of that being said, well, actually, before I go into an example, are there any questions about that, just what you're doing, what I expect from you guys for this activity before going into an example? Perfect. Okie dokie. So like I said, I'm going to go through an example. I'm not going to use any of the topics that are there because I don't want to give anyone a freebie. So I'm going to go with mean, median, and mode. So my point is to kind of describe it, understand it, demonstrate my understanding of it. So what are 3 things that mean, median, and mode all have in common? Well, they're all measures of central tendency. Central tendency tends to tell us where a data set is, where the center of a data set, hi Petunia, is located. So all three of these different measures of central tendency get to the core of that in some way. So for mean, one way we calculate that is to, take all the scores or data points we have, add them all together and divide by however many there were. The median, we're lining up the data points in numerical order and finding the center of that. And then with mode, we're simply finding the most. Now, another point I would want to emphasize when describing these three things is not just their definitions, because we're probably familiar with mean, median, and mode from whenever we learned it back in, God, I don't know, elementary school, middle school, high school. It's a blur. I don't know. I was drunk. No, I wasn't drunk. Not in fifth grade, at least. But anyway, so as far as mean, median, and mode are concerned, I think what's really important in understanding them is not just what they are, but when would we use one over the other? That can be kind of a challenging thing. So I'll start with the easiest one, which is mode. Again, that's the one that's the most. Typically, mode is not used by itself for quantitative data. And as a reminder, quantitative data is typically measured numerically. And my quick and dirty method of finding quantitative variables or quantitative data is, can we find the average of it? So if we think of a categorical variable of eye color and the different conditions of brown, blue, green, etc., if I ask you, what's the average of brown? It's like, I don't know. But what do we typically do with categorical variables instead? We count. We count how many people have brown eyes, how many people have blue and green, etc. So that's where mode comes in. For a measure of central tendency, the only one categorical variables can really use is mode, because we can't find the average or the median of blue and brown and green or any of that stuff. So we use mode with categorical variables exclusively. And again, like I said earlier, if we're going to use it with quantitative variables, like, oh, let's find the ages of everyone in the class, I can find the mode of age. Maybe the most people in class are 19. That's the age that is most frequent. Okay, we can still use mode for quantitative variables, but it's not really telling us much in terms of central tendency without the use of mean or median. So mode is more so used with categorical variables. Okay, so now let's switch over between mean and median. And again, I'm going through when we use each of these three different measures of central tendency. I'm not just going off on a tangent with a cat menacingly on my shoulder. Well, she's staring out a window, so she's fine. Anyway, so now we look at mean and median. So with mean, we will tend to find the average of quantitative variables. Both of these are used with quantitative variables. Okay. But with mean, what we usually have when we use that is when our distribution is relatively normal. As we learned from normal distribution earlier this week, it's more theoretical. Not many data sets, if any, follow perfectly the normal distribution. It's mathematically calculated. There's formulas involved. And it's more theoretical. It's like where us statisticians look to and be like, oh, please, oh, that's the perfect data set. It's normal. It's perfectly symmetrical. Oh, but we don't typically find that, at least perfectly exactly as such in a distribution, but it gets relatively close. And so for most data distributions, especially the ones we'll use in our class as we move forward past the first exam, once we start getting into Petunia, once we start getting into the different statistical tests, that's when we use mean, where it's the distribution is close enough to normal to where we can still use it. Now with the normal distribution, I think we typically, prior to statistics or even just kind of casually discussing statistics, as you do with your friends at your dinner dates, you'll have typically we call it like the bell curve, that very just little hump on a branch. But what that is that, a majority of the data falls somewhere in the middle, kind of, and it spreads outward from there. And at the major ends of the tails, it tends to be a lot. Okay, I don't need your butt in my face. That's what I'm saying. So we have the tails that not as much data falls in there, but as it gets closer to the center, that's where a lot of the data lies. Mean is perfect for that because while mean is affected by outliers, you got some on each side, but they kind of even each other out. It's not like what we'll discuss for when it comes to median, where the outliers all kind of fall on one side and it's not really even. So mean is used when we have a relatively normal distribution. Again, that bell curve. It's affected by outliers, but with normal distributions, they're on both sides, so it evens itself out. We can get a general good gist of where the center of the data is using mean. Now for median, where we use mean for normal distributions where it's relatively symmetrical, median is used when we have skewed distributions. In fact, I have a whiteboard that I can draw. Just a moment. Okay, I'm back. So, gotta get a pen. Oh, I don't want to use brown. I want to use green. Sure. All right. So, can you guys still hear me okay? Because I know the board is kind of in the way of my microphone. So are you guys still able to hear me okay? Thumbs up. Perfect. Thank you. So the normal distribution where we use mean looks kind of, it's not perfect because I drew it, so just deal with me. But hey, no, not a lot of data sets are perfectly normal anyway, so it's actually fitting in theme. Anyway, so we have a normal distribution relatively equal on both sides, and that's fine. Mean is perfect for that. For median, it's where we have skewed distributions, where you see that the data tends to kind of tip to one side or the other, where a majority of the data set, it's not symmetrical, equal on both sides, but it's for this one, it's super heavily stacked over here, and it starts to dwindle as it moves in the opposite direction, and vice versa over here. Median is not affected by outliers. So the mean of 125,500 is going to be affected by that 5,000, but the median of 125,500 wouldn't be. The median is still going to be center. So we'll use median when we're dealing with really skewed data distributions like that. So it's not going to kind of lean in the favor of the outliers or in the majority of the data. We don't want that if we're trying to find the center, and mean's going to fall trapped to that every time. Median doesn't. So some typical examples of skewed distributions are, I like to use the population of cities in California. So we have a couple really big cities in the state of California based on, population size. San Francisco, LA, Fresno's actually pretty big considering Sacramento's got a few 100,000, I'm sure. But then, so those are the big ones, LA and San Francisco. You go to anywhere outside of California and you say, I'm from California. They're going to say, oh, are you by LA or are you by San Francisco? And then you got to say the middle. And they're like, oh, what? It's like, yeah, I know. Anyway, but those are the big two. But then you think of there's hundreds of thousands of cities in California, or just towns, honestly, to where, yeah, we have those big ones that have really decent sized populations, but then you stray further and further and you think of cities like Centerville, which have a population of 5, or I don't know, but there's all these tiny little towns, little cities in California that do not have a population that could even closely rival that of LA or San Francisco or Fresno even. So you have a bunch of cities that are in the smaller realm where they have a population of 1,000, 20,000, 10, I don't know. And that would start to skew. We have a few big cities, but a bunch of cities that are kind of smaller. That's a largely skewed distribution because of how, again, if you think of it like scales, all the small cities kind of tend to weigh down the couple of bigger cities that we have. We have way more small cities than we do massive cities in the state of California, or really any state, honestly. But we would use median for that, because again, it's not going to be affected by the 17 million versus the 17 flat. So the big difference as a wrap up is kind of, I defined the different mean, median, and mode, and then I kind of went into when to use each of them. Mode for categorical variables, mean when we have a normal distribution, it's normally distributed, and median when we have a skewed distribution, where we have that imbalance in where the data is set, where it's distributed. So again, this is all to harken back to your in-class activity. Of those 5 topics of variance and standard deviation, normal distribution, categorical versus quantitative variables, samples and populations, or experiment and non-experiment, pick the one that you struggle with the most to explain, to grasp, to just like, pick that one and then write what you know about it. And again, like I said, I have those prompting questions to kind of give you a diving board to jump off from, but write what you know. And then I read all of your in-class activities, of course. And so, and feel free to ask questions within your sentences too, of your descriptions. Like, I don't know, if there's something that you're missing that you want to know, put it in there too. The goal of it is so I can kind of see where your understanding is at and be able to target that specifically and help you in that specific realm you need help with. So there you go. I don't know. I mean, I've kind of gone in circles now, but are there any questions? Because this is all I have for the meeting, since this is really individually based in terms of this activity is concerned. Do we have any questions? All righty. Well, I hope you guys have a fabulous weekend. I know, and now it gets to start a little sooner, although unless you have something to do after this, I'm sorry, but that's not my fault. But have a fabulous rest of your day. Have a wonderful weekend. And let me check for a second. I like to kind of keep us up to date with when our next meeting is. I don't believe we're going to have a meeting next Friday. Checking the schedule. Yes. So the next time we meet will be October 6th, which is 2 Fridays from today. And that will be an exam review. So I'll put a study guide up the week of October 6th, and we'll get a chance to look it over. And the meeting that we have on that day, on Friday, October 6th at noon, is going to be, you guys bring in your questions, looking over the study guide. Let me know what you need more explanation on, where you're struggling, if you need examples on something, whatever. We'll go over the study guide, but you guys provide the questions, I provide the answers. So you guys are in a way kind of running it. I'm just kind of the talking head there. But that's the next time I'll see you all. So like I said, have a fabulous weekend, and I'll see you in 2 weeks. Bye.
I do have a quick question about the homework for this week.
Okay.
For question 2, do we use the Z table that's posted on the modules, or?
Yes. Let me just pull it up really quickly.
Okay, sorry.
No, just to get it exact, so I know exactly what question you're thinking of. It's homework 3.
Mm-hmm.
Yeah, you would definitely use the Z table for all of the different Z scores you'll be using for that homework. Yeah.
Okay, thank you.
Of course, not a problem.
All right, have a good weekend.
You too. Bye.